Okay, so we want to solve, check, and graph the solution set of this equation. So we've already isolated the absolute value. So we just say the inside part, which is x plus 2 equals 3, or x plus 2 equals a negative 3. Okay. So if we solve the one on the left, all we changed was the right-hand side, the part outside the absolute value. So we subtract 2 and then x equals 1, or subtract 2, x equals a negative 5. Okay. Let's just check this really quickly. If we plug a 1 in, 1 plus 2 is 3, absolute value of 3 is 3. Negative 5. Negative 5 plus 2 is negative 3, absolute value of negative 3 is 3. So that works. Let's just see if we were to change this plus to a minus, what would happen. So a lot of times students are tempted to say x minus 2 equals 3. If you solve, then you get x equals 5. But if you plug 5 in, 5 plus 2 is 7, absolute value of 7 doesn't equal 3. So this doesn't work. Okay? So you want to change the part out. You want to get the absolute value by itself and then change the other part, not inside the absolute value, but the part outside the absolute value. Okay. So we want to solve and check. Okay. So we have a greater than, so we do it just like the equal symbol. We're going to say x plus 2 is greater than 3, or x plus 2, and then flip. So it's going to be less than a negative 3. So when you have greater than, you do the parts in red. So now if we solve the left, we subtract 2, x is greater than 1, or if we subtract 2, x is less than negative 5. So we're dealing with negative 5 and 1. Greater than 1 goes to the right. Less than negative 5 goes to the left. And this should be our solution. And in interval notation, it's going to be negative infinity up to negative 5 union 1 to infinity. So these are the main parts. That we're looking for. Say we wanted to check it. So we can choose a number. We basically do pick a number that should work. So you can pick something like 2. So if we plug in 2 into the original, 2 plus 2 is 4. 4 is greater than 3. That works. If we chose negative 6, it should work. So negative 6 plus 2 is what? Negative 4. Absolute value of negative 4 is 4. That works. But if you choose 0, it should not work. 0 plus 2 is 2. Absolute value of 2 is 2. 2 is not greater than 3. So that checks out too. Okay, I'm just going to put this little caution in there. So I'll let you go through this on your own. And then we'll go through this example. So we want to solve and check. So with something like this, we want to isolate the absolute value first. Get the absolute value by itself. Okay. So I'm going to add 9 to both sides. You get absolute value of 5x plus 2 equals 2. Okay. So now we have the absolute value by itself. So we say 5x plus 2 equals 2. Then we say or 5x plus 2 equals negative 2. Okay. So then if we solve from here, if we subtract 2, we get 5x equals 0. So then x equals 0. Or subtract 2, 5x equals negative 4. X equals negative 4 over 5. Okay. So it's a good idea to check these because sometimes you get the right wrong answer. It's like the algebra will be correct, but if you don't check it, it won't work. So sometimes, you want to check it every time. So when x is 0, we get 0 plus 2, which is 2. 2 minus 9 is negative 7. That checks out. Negative 4 over 5. That's going to be negative 4 plus 2 is negative 2. So then absolute value of negative 2 is 2. 2 minus 9 is negative 7. So then x equals a negative 4 over 5 and 0. So we'll make this the last example for this section. Okay. We want to solve each equation and check the solution. So we have two absolute values. So what do we do when we have two absolute values? You essentially do the same thing. So we're going to say the left-hand side, k minus 1, equals the right-hand side, 5x plus 7. Then we're still going to put our or. Then we're going to say k minus 1 equals a negative the right-hand side, 5x plus 7. So if we, and that's a k. That's a k, and that's a k. So if we subtract k and subtract 7, we'll get 4k equals -8. So then k equals -2. Let's distribute this negative here. So then k minus 1 equals -5k minus 7. So I'm going to add 5k. I get 6k equals a -6. So then k equals -1. Okay, we need to check these. So if we plug in -2, we get 3 over here. -2 here is -5. So that's -10. -3 is 3. So -2 checks out. -1, we get a +2 over here. And then if we do -1 here, we get +2 over here as well. So it looks like both of these check out. Alright, so watch this video, take notes as if you're in class. You have your homework posted, and have a good weekend.